All right. Problem 17. Verify that the SI unit of kinetic and potential energy is the joule. Okay. What's this about? I guess they want me to do conversion of units from equations for kinetic energy and potential energy and just show that it results in a joule. Sure. Although it seems like a kind of a basic question. All right. Kinetic energy of a system, of an object, can be calculated by an equation. That's going to be the 1/2 mv squared. Do they introduce that in this chapter? Let's see here. Pressure, 1.6 is pressure, 1.7 is work. Energy, kinetic energy, great. Let's do... Yeah, the equation introduced by Lord Kelvin in 1856. Rich white guy who made his money doing undersea telegraphs, I think. Kinetic energy of an object can be calculated by an equation. The equation on in section 1.8 energy that and we'll just go ahead and quote it here because in Smith there we go. Where then we'll go ahead and list the definitions of the different variables. So M is the mass and this U thing is velocity. And the units of mass are kilograms. Velocity is meters per second. Using dimensional analysis, the units of... Oh, we gotta put an E, don't we? E sub k is the kinetic energy. Units of E sub k may be found like so. We'll go ahead and add in a table of equations. We'll go ahead and see if this notation works. Units of M times units of U squared so that will be kilograms times meters per second squared, which is going to be equal to kilogram come on, meter second squared, and that meter is also squared. we're going to multiply by 1, but that 1 is going to be, see, joules. You want joules, right? Yeah, okay. Definition of a joule is Newton meter. So let's convert this into newtons. So for every newton, we have a kilogram. Actually, kilogram meter per second squared. And then to get to joules, we'll need, for Newton meter, we have a joule. All right, so let's gather some terms. Newton, kilogram, meter, second squared, joule, Newton, meter. Okay, so everything should cancel out except for the joule. Yeah. And I could go piece by piece, but if you just look at that equation, you should see. There we go. I guess that's kind of what they were wanting me to show. Yeah, so I just introduced me newtons and then Newton meter, these two conversions. And yeah, joules, great. Kinetic energies in joules. Let's go ahead and add some numbers to these equations. Using dimensional analysis, the units of, well, let's see. First off, we need an equation for potential energy, so we'll pretty much do the same statement as we did here, except we'll replace with potential energy. Potential energy of an object can be calculated by the equation in section, not energy, but, well, yeah, it's still energy. EP okay, mass times a change in elevation, I guess. We've got to do the same where. We'll define everything. Where E sub P is M is mass, Z is elevation. G is gravitational acceleration. It's going to be meter per second squared. Okay. And we'll just say, using dimensional analysis, E sub P may be found like so. We'll do the same thing as we did before, except with this new equation. Units of E sub P is equal to units of M times units of Z times units of G. So units of M are going to be kilogram times units of Z, which are going to be meters. Oh, the dog. The dog. Okay. Units of G, which are going to be meters per second squared. Great. Equals, and then let's combine these things. Kilogram per meter squared, second squared. And then let's go ahead and apply. Let's see, dunt. Multiply by 1, which is going to be the quantity kilogram meter squared. Do we have the same thing? Yeah, it's just the same thing. Great. I mean, I'm not sure what they are going after from this. Yeah, Newton. Yeah, it's just the exact same thing. Except the end result is, instead of a E sub K, it's just E sub P. Answer. Problem 16 answer. Is this 16? 17. I mean, it's kind of just... Okay. Units of kinetic and potential energy are in joules. Great. Okay, that's pretty much it. Let's go ahead and save that. Export PDF. Save it. Stage both of those. Chapter 1, problem 17, add solution. push the change. Okay, done. Now for